Okay, we're almost reaching the end, so bear with me for another 15 minutes and then you can plan for your dinner or whatever fun things you're gonna do tonight. I only have 15 minutes to wrap up 6 concurrent sessions. I'm not going to go over the plenary sessions because all of us were attending that. So as you know, as you have seen in the program, we had 6 concurrent sessions. I managed to get myself only in 2 of them, which is what normal human being would do. So I relied on the moderators for all 6 to give me a short summary, and I assigned it as a homework, and as students in my class, they will always do more than what I ask, so I get a lot more than what I needed. So the first concurrent session had to do with impact of ground motion on bridge performance and design. So Sashi Kunath and Don Lehman did a very good job in summarizing the key points. A lot of text, so I'm not going to read everything. We will put all this in a final set of slides that will also be included with your presentations. But a few highlights. The general theme of this session was the impact of ground motion on bridge structures. So there were several presentations. One presentation summarized an ongoing research between UNR and Stanford. This is funded by peer, and it focused on the effect of long duration ground motion on bridges. It had an analytical component, and like every good researcher, never do a shaken table without doing some analysis before. These are dangerous devices, and it will break your specimen unless you know what you're doing, and they are doing that, and they're getting ready for some shaken table tests to follow. So that's great. Second presentation by UNR is looking at the effect of vertical ground motion on isolated bridges, identifying some important key points related to amplification of base shear due to the vertical acceleration. Wow, am I good? How can I remember all this? Anyway, so what they try to answer next is, does base shear amplification depend on bridge and isolation characteristics? And a third presentation by UCLA focused on aftershock vulnerability, where they subject their structures to main shock followed by aftershock, and they use Markov chain, and they try to understand the effect of aftershock. They looked at 3 eras of the systems of the bridges they looked at: pre-1970, 71 to 89, and modern Caltrans bridge. And this is an important research which is going to have big effect on post-earthquake functionality and repair priorities, strong link to resiliency. The last presentation by University of Washington looked at the impact of a magnitude 9 Cascadian subduction zone, important study, and some maps of effective spectral acceleration and regional collapse probabilities were developed. I think this is very important to the state of Washington and other subduction vulnerable regions. So the second concurrent session had to do with geohazard. Tom Chance was the organizer of this session. He couldn't make it. He asked Yusuf Buzurgania to fill in for the moderator. This one I got short input, just listing the what was covered, which is also important: non-ergodic ground motion modeling, 3D physics-based simulation, design spectra, quantification of basin effect, modeling of ground motion for subduction, also some subduction work. Now we can move to the third. So the third concurrent session had to do with computation simulation of geotechnical and structural system. I also attended this one, but Greg Dearline was the moderator, and he did a great job in summarizing this. And I used his as a template, so I will blame Greg for the lots of text because everybody copied him. So the summary of this, there were 5 presentations. I can say this off my head because I attended. There were excellent presentations focused on modeling soils, from very detailed modeling of the grain size and shape based on X-rays to constitutive models that have really the way it was presented, it shows how a good programmer and someone who understands the physics of the problem go out of his way to make sure what is being implemented is actually follows the intention of the physics. So that was very good presentations. The summary or the key points of this session is the dissemination of the nonlinear computational modeling tools. Lots of comments about that, how we get these tools into the SimCenter tools or in the design safe, and so there are lots of these are available at the moment. Development and validation of the models, lots of discussion about that. Very useful, whether you use another program to validate what you are developing, like what in the geotechnical, where they compare things with FLAC, or comparing it with available experiments of different forms. On the structure side, people were testing or developing models for masonry structures and going out of their way to compare with existing experiments before they actually use these models in assessing structural systems. Simulation-based engineering and comparison with virtual experiments, very interesting work using discrete element models and comparison of that with available other type of simulation. To the point that you start trusting the simulation that will serve the purpose of virtual experiments. So you can use that to run lots of cases, and you trust the results as if you are doing an experiment. The last point here is support of innovative design and performance assessment. So this session also included some innovative design system that is made of laminated wood structures, and it's a rocking system that was presented in a very elegant way, and also some other traditional structural components like masonry walls or concrete walls. And associated to these experiments were also the corresponding computational models. The fourth concurrent session focused on new trends in seismic design of bridges. And so we had 2 sessions on bridges, one focused on effect of ground motion and the other focused on new trends on bridge design. So Don Lehman and Bijan Khaliji were the co-moderators of this session. And unlike these other sessions on bridges, the focus here on new trends of seismic design of bridge structures. So there was a presentation by Bijan from Washington Department of Transportation, which included some of the challenges that WashDOT is facing in relation to accelerated bridge construction. Some projects were presented. This included new design and construction concept, including shape memory alloys or ultra high performance concrete and self-centering columns using unbonded post-tensioning. This was followed by, this is probably the UC San Diego session, because there were 3 presentations from San Diego. One summarized the ongoing Caltrans projects to develop simplified performance-based methodology for ordinary standard highway bridges. Some detailed open seas models were presented. Peer performance-based design methodology was exercised. Several parameters were valid such that a feasible design space can be developed. So this was the focus of the study. Another study by UC San Diego was focused on the ongoing research between San Diego and Berkeley, looking again at resilient bridge design that can be used for accelerated bridge construction. So as you remember, last year we had the blind prediction for the shaking table experiment. So this was presented, and also the future plan of the counterpart of this test to use hybrid simulation, which is under preparation at UC Berkeley at the moment. Some pre-test analysis were also presented that showed good agreement with the experimental results. The final presentation, also from San Diego, focused on using grade 80 reinforcement in bridge columns in California. Several parameters were looked at: ductility, development length, anti-buckling reinforcement, and low cycle fatigue behavior of high strength reinforcing bars. And one of the important conclusions is the seismic design criteria equation for the yield penetration. I said here may, I don't want to scare Caltrans, may need to be changed, and anybody from Caltrans talk to Jose Restrepo, what needs to be changed. But however, there are other things in Caltrans seismic design criteria seems to be good. The embedment length requirements are satisfactory. The column attained 8% drift at fracture of the bars. The second geohazard concurrent session was moderated by Scott Brandenburg. He couldn't be here, and he said, if I get stuck, I ask John Stewart, and if I get stuck, please correct me. Again, this is one that has a lot of text. So the summary of his comments is that there were excellent presentations focused in geohazard. They had two themes in this presentation. One was dominating by the number of talks, which has to do with liquefaction hazard. The other, because it only had one talk, was the tsunami hazard. So in the liquefaction hazard, the common theme of the session was that actually, this echo one of the comments I made in my opening remarks, is we live in an era of data now. So the amount of data that is available in the quantity and in the quality is much larger than the legacy case history data. So this has direct impact on how research is done. Size is very small. I have to take off my glasses here. So the site investigation techniques have shifted heavily towards cone penetration testing. I think I heard that also from John Bray in his lecture, which has superior reproducibility to standard penetration test. The number of site investigations has also increased significantly, particularly after the Canterbury earthquake, and the ground motion records are far more large now, so this definitely has a big impact on the research related to soil liquefaction. There were also some important comments about the geotechnical models that provide enhanced ability to predict the effect of liquefaction, but some challenges have been pointed out by several of the presentations. And there were also a presentation about the next generation liquefaction project and the availability of the database in the design safe by writing a Python script in Jupyter notebooks. I think this is available already or will be available soon, or yeah. So there were also discussion about the re-evaluation of the lower San Fernando Dam case history with comparison to the observations using advanced constitutive modeling, and the prediction of the deformation using these models were reasonably validated. There were some differences that were explained in a reasonable way based on the assumptions that are considered related to the undrained residual strength and the strength loss potential in the clay. I guess these are important, challenging problems that should keep the research in this area going. The last was the tsunami hazard, and Professor Lynette from University of Southern California, who has been leading this effort, presented the probabilistic tsunami hazard analysis, how it can be performed, and how what are the intricacies of this, and how this can be converted to, or the results can be converted to inundation maps. This translation requires certain effort, and that was pointed out. Also, there were discussion about the tsunami wave or loads generated from the tsunami wave, and how these differ depends on the whether there is water loads on the bridges, whether there is water under the bridge or not, or at least that's what I understood. The last concurrent session, I also attended that. This was a focused session on single-family dwellings, and Jim Malley and Janil Maffei were the co-moderators of that, and also Janil give a good introduction of the session and also good conclusion of it. So in the introduction and conclusion, I put them in one slide. The CAA formed after Northridge earthquake damage created insurance crisis, even though 12.5 billion in insured costs to Wood residents, but damage was greater than that. Curie Wood Frame Project tried to understand the challenges involved, the adoption of retrofit standard in 2010, and some of the funding, and that's good news, of the CAA is set aside for research. We like to hear that. ATC 110 and FEMA 11 or 1100 developed standard plan for retrofit of single-family residences, and peer program includes testing, which is also funded by CAA. And some of the plans for future CAA mitigation program is to expand the brace and bolt program. For example, consider hillside conditions, support building departments in establishing residential mitigation programs, provide retrofit incentives for small multifamily structures, 5 to 10 units, development of post-event survey program, and this one I really like is to support development of building inventory technology using artificial intelligence and machine learning. So this is catching on. Kelly Cobbin give a very comprehensive overview of the ATC 110 and FEMA P 1100. FEMA P 1100 pre-standard has been published and is available. It attempts to develop resources for assessment and retrofit that defines the method, minimum level, and thereby facilitate the implementation. It's established the optimal retrofit capacity. Standardized plan sets are to be published soon. A date was not given, but shortly is good enough. Intended to update the documents based on future developments from the peer work and add additional vulnerabilities not yet addressed. Peer CAA project was also presented that focus on improve the knowledge on resilience of wood frame construction based on testing and analytical research, and also to seek more understanding of damage state to help develop fragility function. So some of the tests in San Diego, some of the tests in Berkeley, and also lots of simulation in Stanford were summarized. And the test program focus and goals in both San Diego and Berkeley were outlined with some preliminary results shown, and also exercising P58 models in open seas were presented, and continuing work on additional variants and mining photo data database for educational purposes, and looking into the effects of modeling uncertainties is some ongoing work. And with that, I stop. I'm only 5 minutes past the deadline. So I wish you safe travels wherever you're going. If you are from LA area, drive safely. Don't look at your cell phone while driving. And if you are flying, go to the airport early. You never know with the government shutdown how long it takes. I was delayed coming here 4 hours. I hope it's not going to be the same in my way back. But I have relaxed travel tomorrow. So thank you all for coming. And if you have any input, please send us email. If we have done something good, you don't have to email us. If we have done something bad, please email us so we don't do it again. Thank you.